Okay, so there's two ways that we can go about doing this. The first is we can make a common denominator. Okay, so common denominator would be 3 plus 8i on the top and 3 plus 8i on the bottom. And then over here, I would do 3 minus 2i, 3 minus 2i. So that's one way that we can do it. So let's go ahead and try this way out. So my first fraction will be a 3, and I believe that's an I up here. So let me just double check real fast. Yes, that is an I. So this will become 3i plus 8i squared, and then plus, and then over here this will be a 6i, and then minus 4i squared. All of this will be over the same denominator. So let's multiply that out. So this will be a 9 minus 6i plus 24i minus 16i squared, right? So collect our like terms. So I have, oh, I forgot the squared on that guy. So I have 9i plus 4i squared on the top, and on the bottom, this would be, so negative 6 plus 24, that should be what, 18? So 9 plus 18i, and change that guy to a plus 16. Bring it up over here. So this will be negative 4 plus 9i, and then 25 plus 18i, so to speak. I will go ahead and now multiply by the conjugate. So 25 minus I squared, 25 minus 18i minus 18i. So let's go ahead and multiply all this out. So I will get negative 100. 18 times 4 will give me a positive 72i. 9 times 25 will be a positive 225i. And then finally 18 times 9 will be negative 162i squared. On the denominator, 25 times 25 gives you 625. I'm not going to go ahead and multiply those numbers because I know that they're going to cancel each other out. So I'm just going to multiply 18 by 18, and that is going to give you 324i squared. Whew. All right, so we got some adding to do. So this will be a negative 100 plus 162, and then add my i's together. So 225 plus 72 will give you 297i. And on the bottom, 625 plus 324. All right. So what do I have? I have 62 plus 297i all over 625 plus 324. So that would be a 949 as our answer, right? So we can leave it like that, or I can write it as 62 and 949, 297 over 949i. So that is definitely one way that you can do this problem. If you wanted to do it a different way, so what was it? I over, I think it was 3 minus 2i, and then it was 2i over 3 plus 8i. What you could do is you can think about this problem and write this as the a plus bi and then a plus bi. So I can multiply by the conjugate, and then focus on that. So this would be 3 plus 2i, 3 plus 2i, and then this will be 3 minus 8i, 3 minus 8i. So that's definitely one way that you can go about doing that. So what that would look like would be this. So 3i plus 2i squared, and then 9 minus 4i squared. And then over here we'd have 6i minus 16i squared all over 9 minus 64i squared. So what does that give you? Negative 2 plus 3i, and there'll be a positive 4, so let's just say 13. And then over here, we're going to say 16 plus 6i, and then 9 plus 64. So that will be 70, should be 73. Let me double check. Oops. So 9 plus 64 is 73. Perfect. So what can I do next? Common denominator. So I'd multiply 73 on top and bottom, 13 on top and bottom. So 73 times 2. Boop, 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 boop. Let's put it all over here. So that's going to be a negative 146. And then plus 3 times 73, so 219i. And then let's go to 16 times 3, so plus 208. And then 6 times 13, so plus 78i. And then 73 times 13, 949. So if we add these numbers together, so 208 and a negative 146 should be 62. And then 219 plus 78 should be the 297, which it is. There's not supposed to be a negative right there. Don't know why I put that there. And 949. And that should have been the same thing that we got right here. So this problem, two different ways that we can solve it, and still produces the same exact result.